Hello and welcome to our lecture on virtualization basics. In this lecture, we'll dive deep into what virtualization is, how it works, and its relevance in modern IT environments. We'll also explore the software-defined data center, SDDC, and how it builds upon virtualization to provide a scalable, efficient, and modern IT infrastructure. Virtualization refers to the creation of virtual, as opposed to actual or physical, versions of computer resources, where software simulates the functionality of hardware. In a virtual environment, a number of virtual resources may be created from one physical resource, or one virtual resource may be created from multiple physical resources. Virtualization allows organizations to operate multiple operating systems and execute numerous applications on a single server, thus enhancing efficiency and scalability. The virtualization architecture can be best understood by contrasting it with traditional architecture. In traditional systems, a single instance of an operating system runs directly on the hardware, consuming all available resources. However, in a virtualized system, a virtualization layer sits between the operating systems and the hardware. This layer logically partitions the hardware resources based on the requests from both the host and the guest operating systems. The host OS interacts directly with the hardware, while the guest OSs interact through the virtualization layer. This enables a much more efficient utilization of resources. Before virtualization, organizations had to purchase separate physical servers for each application. This meant each server required its own operating system, leading to increased costs, complexity, and inefficiency. Physical hardware was often underutilized, and running multiple applications on one operating system created security vulnerabilities and performance bottlenecks. Deploying more applications required acquiring more hardware, resulting in higher costs, more power consumption, and increased space requirements. At the heart of virtualization is the hypervisor, a specialized software layer that manages virtual resources. It allocates physical resources such as CPU, RAM, and storage to multiple virtual machines, VMs. The hypervisor ensures that each VM operates independently, even though they share the same underlying hardware. There are two primary types of hypervisors that support virtualization: Type 1, bare metal, and Type 2, hosted. In Type 1 virtualization, the hypervisor is installed directly onto the physical hardware and acts as the primary operating system. This approach provides high performance and efficiency, making it ideal for large-scale enterprise environments and data centers. VMware ESXi and Microsoft Hyper-V are examples of Type 1 hypervisors. In contrast, Type 2 hypervisors are installed on top of an existing operating system. While this model is easier to set up and more suitable for smaller environments, it introduces some performance overhead due to the dependency on the host OS. Examples include VirtualBox and VMware Workstation. Different approaches to virtualization include full virtualization, where the guest OS is unaware of being in a virtual environment and interacts with hardware through the Virtual Machine Manager, VMM. In contrast, para-virtualization involves the guest OS being aware of its virtualized environment and directly communicating with the host machine for resources. Modern processors also enable hardware-assisted virtualization, allowing the guest OS to execute privileged instructions on the processor directly. Hybrid virtualization combines elements of both para-virtualization and full virtualization to create an optimized system. The benefits of virtualization are significant for modern IT infrastructures. Reduced hardware needs is one of the primary advantages, as virtualization enables multiple virtual machines to run on a single physical device, reducing the need for dedicated hardware. This cuts capital expenditures and minimizes the carbon footprint of data centers. Efficient resource utilization is another major benefit, as virtualization dynamically allocates resources to minimize waste and ensure that physical hardware is fully utilized. This results in improved power management and lower operational costs. Further virtualization can occur at various levels, including storage device virtualization, e.g. RAID, where multiple physical storage devices are combined into a single logical unit, and file system virtualization, which abstracts data at the file system level to facilitate better sharing and protection of information. Server virtualization enables the partitioning of the server's operating system environment, allowing the server to run multiple operating systems. Fabric virtualization involves abstracting storage and network devices to create vast resource pools that different virtual machines can utilize. Beyond the technical details, virtualization also enables operating system virtualization, which allows multiple operating systems to run simultaneously on the same hardware, and network virtualization, where physical networks are combined into virtual networks, abstracting the underlying physical resources. The next step in IT infrastructure is the software-defined data center, SDDC. SDDC takes the principles of virtualization and extends them across the entire data center, abstracting hardware resources such as servers, storage, and networking into a software-controlled environment. This abstraction enables more agile and responsive management of IT resources. By virtualizing the entire infrastructure, SDDC allows businesses to rapidly scale resources up or down to meet changing demands, improving scalability and overall efficiency. SDDC offers numerous benefits, including improved scalability, as resources can be quickly provisioned or decommissioned as needed, and enhanced agility, as IT operations can be automated and managed centrally. This automation reduces human errors and speeds up deployment times, giving businesses a competitive edge. Virtualization also lays the foundation for many modern IT innovations. Cloud computing relies on virtualization to create dynamic, scalable environments that can grow or shrink according to an organization's needs. Beyond the cloud, virtualization has paved the way for technologies such as containerization, which further optimizes resource usage, and serverless computing, which abstracts server management entirely. Software-defined networking, SDN, and software-defined storage, SDS, are other innovations built upon virtualization principles. Virtualization has transformed IT infrastructure, providing scalability, cost efficiency, and flexibility. It serves as the backbone of cloud computing and is a crucial enabler for emerging technologies such as containerization and serverless computing. The future of IT will continue to rely heavily on virtualization, particularly as the move toward SDDC, SDN, and SDS accelerates. These innovations will drive even greater levels of automation, flexibility, and efficiency. I hope that was clear for you, and I look forward to seeing you in the next session.